When you get in your car, what are you really driving? I'm not talking about the engine or the transmission. I'm talking about the millions of lines of code that make it all work. Today's car is basically a supercomputer on wheels, and its software is just incredibly complex. So in this explainer, we're going to pull back the curtain and meet the mastermind behind it all.
And that's the huge shift right there. We're not talking about a nice-to-have feature anymore. The software is the experience. How your car performs, how it keeps you safe, the entertainment, all of it. It's become the very soul of the machine.
So that begs the question, right? Who's the master planner? Who is conducting this incredibly complex digital orchestra? Well, let's dive in and find out. That person is the vehicle software architect. They are the hidden genius, the one making sure hundreds of different systems all play nice together, and most importantly, that they do it safely every single time.
Think of them like the chief city planner for your car's digital world. They don't just write a single piece of code for one building. No, they design the entire city grid, the roads, the power lines, the communication networks, making sure everything connects and flows perfectly. And their to-do list is, well, it's huge. They're juggling everything from the big picture system design all the way down to the nitty-gritty of how different parts of the car talk to each other. But look at this list. Two things really jump out: functional safety and cybersecurity. For an architect, those aren't just items on a list, they are absolutely non-negotiable.
Okay, so how do they actually build this digital car? What does the blueprint look like? Well, it's all about layers, built from the ground up, just like a skyscraper. And it all starts right here with the physical world. The foundation is the actual hardware. We're talking about the electronic control units, or ECUs, which are basically a bunch of tiny computers, plus all the sensors that are gathering information and the actuators that are making things happen, like, hitting the brakes.
Now, sitting right on top of that hardware is the base software. This is the really fundamental code that lets the hardware do its job and, crucially, lets it talk to other parts of the car using languages like CAN and Ethernet. It's kind of like the basic operating system for each little component. Next up, we have the middleware, and this is where things get really, really clever. This layer often uses a standard called AUTOSAR. Think of AUTOSAR as a universal translator. It lets all sorts of different applications run on different types of hardware without having to be completely rewritten from scratch every time. It's a total game changer.
And finally, we get to the top, the layer that you, the driver, actually interact with. This is where the magic happens. Your advanced driver assistance systems, that big infotainment screen, the brain that manages your electric motor, all of it is built on that rock-solid foundation we just walked through.
And this is a great way to see how the architect organizes all of that complexity. They group everything into what are called domains, kind of like different departments in a company. You've got the ADAS domain handling safety, the infotainment domain for your music and maps, and so on. Each one is a specialty, but the architect makes sure they all communicate flawlessly.
I mentioned AUTOSAR before, and it's so critical. So let's break it down. You can think of it in two main flavors. First, there's classic AUTOSAR. It's like a trusty old calculator, unbelievably reliable and fast for simple, critical tasks like firing an airbag. Then you've got adaptive AUTOSAR. This is more like your smartphone. It's built for powerful computers, can run complex apps for things like self-driving, connect to the cloud, and get updated with new features.
But with all this amazing, complex technology, there is one rule that trumps everything else. Because when you're writing the code that controls a car's brakes or its steering, failure is simply not an option. In this right here, this is their Bible. ISO 26262. It's the international standard for functional safety in cars. Every single decision that has anything to do with safety is measured against the standard. Its whole purpose is to prevent unreasonable risk. So how do they manage all that risk? They use a grading system called ASIL. It's a way of classifying just how critical a piece of software is. So a glitch in your radio, annoying for sure, but probably low risk, maybe an ASIL. But a failure in the automatic emergency braking system, that's a whole other ballgame. That's going to be ASIL-D, the highest level, and it demands the absolute most rigorous design and testing you can imagine. So how do they figure out that ASIL level? Well, it all comes down to this pretty straightforward formula. They ask three questions. How severe would an injury be if this part failed? How often is the car in a situation where this failure could happen? What's the exposure? And finally, how easily could the driver control the car to prevent a crash? The answers give you the ASL level. Now, having a super solid and safe architecture isn't just about what your car can do today. It's what unlocks the future. It's what allows your car to actually get better over time.
A perfect example is over-the-air, or OTA updates. The architect designs the whole system so the car can securely get an update from the cloud, check to make sure it's legit, install it on the exact right computer, and, this part is absolutely key, safely roll back to the old version if anything goes wrong during the update.
And you better believe making that process secure is priority number one. They use all sorts of tech, like Secure Boot, to make sure no malicious code can ever run. And they use things like Delta updates, which only send the changes to the code, not the whole thing, which makes the update way smaller and faster. It's an incredibly sophisticated dance.
So after hearing all that, you might be wondering, okay, that sounds intense. How do you even become a vehicle software architect?
Well, there's a pretty clear path. Most people start out as a developer, maybe focusing on just one single ECU. From there, you might move into a systems engineering role, where you start to look at how a bunch of ECUs work together. And with that experience, you can take that step into the architect role and maybe even one day lead an entire domain or become the chief software architect for a whole company.
But the secret to climbing that ladder isn't just about being a brilliant coder. It's about developing this big-picture, vehicle-wide perspective. It's about having a safety-first mindset baked into your DNA, and of course, having deep technical knowledge across a ton of different fields.
And really, it all comes back to this one idea. The work these software architects do, it's the invisible backbone that the entire future of mobility is being built on. It has to be strong, it has to be safe, and it has to be ready for what's next. And that leaves us with a pretty fascinating question to think about. As our cars transform into these powerful, connected data centers on wheels, who's the next great innovator going to be? The person with the wrench or the person with the keyboard? What do you think?